down. But if we look at these two wine barrels, right, we're measuring ethanol content. My general hypothesis is just looking at the data, they appear to be the same, right? So the ethanol, my general hypothesis would be the ethanol content in these two wine barrels is the same. The null hypothesis, though, what would we say for the null hypothesis? Somebody.
That barrel 1 and 2 have the same amount of ethanol. It's statistically the same.
Yeah.
Within, and then don't we have to have a confidence interval?
We have to have a level, yes.
Okay.
So we would say that we have to go to the analyte, which is the ethanol. So the percent ethanol content in barrel 1 is going to be statistically the same as barrel 2 at the 95% confidence level. So the next thing that we are going to do Simpson says his old eyes could not see the giant screen 2 feet in front of him, so he needed me to blow it up. Right. See? All right. So, thank Dr. Simpson. So, the next thing that we said we would do in your ocean water for all of these was the so-called descriptive statistics. So what kind of statistical values can we talk about that will describe this data set here? What kind of things would we have? Anyone?
Including in the classroom. That's an answer too.
What kind of things describes the ethanol content in barrel 1? When we have data, what's one of the things we always do?
The average.
An average, right? So we can calculate the average, which is just what else do we talk about in terms of describing this data? What? Standard deviation. And I'm going to abbreviate it that way because that's the way. If we look here on Excel, Excel gives us 2 different standard deviations. Actually gives us 4. We're going to talk about these top 2. What's the difference between standard dev.p and standard dev.s? Anybody?
Population and sample.
Population and sample. So one of them we're going to approximate to all the samples in the universe, right? The entire population of wine barrels. The other, we're just talking about the sample. Because of the limited sampling that we are going to be doing in this class, we are always going to use the S version, right? We are not going to try to extrapolate out to the entire population of anything. That makes sense? Can I get an amen? This feels like a preaching up here. Okay, so just to be clear, when we look at your data, it has to be the .s. If you do the dot or just standard dev, the old school, it will be actually the p-value, the .p. So that's the standard. So make sure you put the S in. So we are going to figure out which computer I'm looking at. We're going to calculate standard deviation. Right? What other things describe this data set? We can do relative standard deviation. Right? We're not going to, but we could. Not yet. Not yet. What else? If you look at the way we sort of perform the t-test, one of the things that's going to come up a lot is we're going to need the number n, which is the count, how many data points we have. Right? And here, when we have, what is that, 6, that's not a hard thing to estimate. But because we're lazy and we could have more data, we're actually going to use Excel to do this because Excel can do this. Right? Using the count function, equals count. Right? What other things could we be interested in knowing about this data?
Would we need the degrees of freedom?
We need the degrees of freedom. Right? And that degrees of freedom is always what? N minus 1. That's going to be the count. Well, true. But we'll come back to that statement in a minute. Right now, for this data, yes, the degrees of freedom for this single data is the degrees of freedom minus 1, or count minus 1. If we're concerned about an outlier, some data that doesn't fit, where is that going to be? It's going to be on one of the two extremes, right? It's either going to be the highest one or the lowest one. Rarely are we worried about a point in the middle. So we're also going to find the max and the min, right? Simply so that we can look for outliers. So again, Excel will do this. I know it sounds sort of strange to be letting Excel do all of these when we have 5 or 4 data points, right? But we're not always going to have 5 or 4 data points. We're going to have a lot. So like if you look at my dissertation research when I was a graduate student, we ran I-scores, and we ran, I think in one of our I-scores, we ended up with something like 6,000 data points. So when you're running with 6,000 data points, any little bit of help you can is important, right? So that's why part of the reason we look at this. And the last thing that we're going to do is define what we refer to as a confidence interval, which I'm going to abbreviate as a CI. So this is one of the things that we described in the book that says, instead of talking about the data as an average plus or minus a standard deviation or plus or minus some error like we've been doing, because we've defined our confidence level, we're going to define a region around the mean that we are confident the actual value should fall in. So So when we write a confidence interval, it's going to be the average plus or minus some amount. And when we do that, how do we calculate that some amount from the textbook? How do we calculate a confidence interval? Anybody remember? I don't know why I'm just looking at people in the room. Anybody out there remember how we calculate a confidence interval?
I think it's like TS divided by the square root of n.
So TS divided by the square root of n. So we need the t, which is a t-value, which we have to look up. We need s, which is the standard deviation, divided by the square root of n, which happens to be the count, right? So if I put the t-value here, so I'm 95% this is the right function. Let's see what it pops up. Right, so it says that distribution, so that's 95%, 0.09 or 0.05, and degrees of freedom is that one. And that was not the right That's the right one. So to look up Excel, look up the t-values, you can use t.inv.2t, put the percentage, the probability as a decimal. So we're talking about the probability of it falling outside. If we have 95% confidence level, probability of being outside that is 5%, 0.05, and then the degrees of freedom, which we have above, right? The other place you can find this is in the textbook. We have a nice table that gives you a whole bunch of, based on the number of replicates and your confidence interval, that value. And if you look at it, it's 2.57 is the table value. Right? I've been doing this long enough that I just know that because I'm a nerd. I don't feel like you need to know that. Questions on that? All right.
Plus Excel just looked it up for you, too.
And besides Excel, but that's also, I knew what it was because when I did the other one, that number didn't make any sense to me. So I knew I had the wrong function. So we said that this confidence interval is T. Go back and put it in T times S divided by the square root of N. So when I refer to it in here as the confidence interval, that's the plus or minus part, right? And because I am lazy, I'm going to calculate what I call the CI high and the CI low, which is going to be the two value, the range values. So this is going to be the average plus the confidence interval. This one's going to be the average minus the confidence interval.
Can you show me B15 again, just your confidence interval?
So it's the t value times the s value, the standard deviation, divided by the square root of the number. Can you see that?
Yeah.
Okay.
How did you do the confidence interval high and low again?
It's just the high
okay,
value
yep.
is the average plus the standard, or the confidence interval. Low is the average minus the confidence interval.
Thank you.
All right. Other questions before we move on? All right. The beauty of Excel is if we want to do all of these same calculations for barrel 2, we just drag it over. Boom goes the dynamite. We're all done. So, questions on that? The last thing that we're going to do, you've done this before, is we are going to insert a text box. Ooh, a ginormous text box. Down here, and we are going to we've come to a stopping point that describes our data, right? So this pretty much is the descriptive statistics that we talked about. So since we have now descriptive statistics, we need to state that. So the ethanol content in barrel number 1 is 12.605.
What are you looking for?
Plus or minus.
Mm.
There's plus. Getting balls up. Maybe not. Where's my plus or minus?
Did you just go to insert and then symbols? It
Yes.
normally, do you not have recents?
You're seeing what I'm seeing. So I can add a car.
That just represents plus or minus.
Use that okay. Just use a random thing and we'll know what you're talking about.
Sure you will.
So we won't waste any time.
Now it's a mission. I'm gonna put the flag of Ecuador in. Why do I have flags but not plus or minus? Stupid Apple.
Yeah, it's Mac. Mac problem. There it is.
Apparently I have to add an equation. Plus or minus 0.011. Right? So now we're saying in this confidence interval, what it says is within this range, we have a certain confidence that our true value falls in there, right? So this range is going to be essentially taking up the place of what we did before when we calculated error or propagated error. That propagated error was only from our measurements, right? In these titrations, there's a lot of other potential errors that can be involved. This confidence interval should account for those errors. So when we write the confidence interval, that's taking the place of our propagation, right? So the good news for today is you no longer have to propagate error. You still have to know how to propagate error, but you no longer have to do it because our confidence interval is taking its place, right? So we're going to write this just like we did before, where we go to the correct number of sig figs plus one digit, which we go back and subscript.
So just if you want to remind people, there's a lot of people who put the wrong number of sig figs in the subscript.
According when we did the last one, or the last assignment, people were not doing the correct number of sig figs and the subscript. So we're going to be looking for this with the correct number of sig figs. This ends where this starts. And then the next digit, unrounded, is going to be subscript. And because I'm putting this text box here, I'm going to leave all of these up here today. You could probably shorten them some to make it less pretty, but this sort of trumps this, right? At the 95% confidence. And then we can do the same thing for barrel 2, which has an average of 12.52. Subscript 2 plus or minus 0.027. And this unit comes from the fact that this is in the problem. It says ethanol content as a percentage, I believe. So this should have the appropriate units. And I made my text box overly big. Okay. Questions on that? So whenever we describe descriptive statistics, this is what we want you to have. Average, standard deviation, count, max, min, t-value, confidence interval, and then the range. Right? If we had a true value and we're doing a case one, we would just be seeing if the true value falls in the confidence level, right? So we would be looking at this range or this confidence level and see if that true value falls in there, right? If it does, then they're statistically the same. If it doesn't, they're statistically different. So case one t-test is primarily descriptive statistics and a simple comparison. Questions on what we're at now? Okay, so if we go back here, the next thing we need to do, so that was calculate all appropriate statistical information and including the confidence intervals, and then carry out a Grubbs test and an F test where appropriate. So the Grubbs test allows us to determine if we have an outlier or not, if one of our data points is statistically outside of this confidence interval, essentially-ish, right? The Q test, which is on that, is another test which does essentially the same thing. They just mathematically do different things. So we are then going to run the Grubbs test. All right, so we're going to run, like I said, if we have an outlier, it's going to be either the maximum point or the minimum point. So I'm going to run a Grubbs test for barrel 1. And then we're going to run a Grubbs test for barrel 2. So for this, we're going to have a G value calculated for the high, a G value calculated for the low, and what I'm going to refer to as the G table. All right, Excel will not look up these Grubbs values for you, so somebody is going to have to look them up in the book, and I should have compared and brought my book, but I didn't.
Chapter 3, page 80.
Chapter 3, page 80 in the latest, or the
80 has the
80 has page 80 in the latest, or not, the version we asked you to get of the book, and 81 is the table. So if we look at this for, on the table, it says number of observations and then the G value. So for table 1, or barrel 1, we had 6 observations. So from the table, that gives us a G value of 1.822. For 4 observations, we have 1.463. Again, you have to look these up. On the table. And then to calculate the Grubbs, that's going to be equal to the absolute value of the questionable point. Since we're doing the high, that's the maximum, minus the average, divided by the standard deviation. So the Grubbs test is the absolute value of the questionable point minus the average divided by the standard deviation. This one would be the absolute value of the questionable point, which would be the minimum, minus the average divided by the standard deviation.
Can you click on
No.
your, okay, never mind.
I will in a minute. Hold on. Questionable point minus the average divided by the standard deviation. I thought one of them fell in. All right, so what do you need me to click on?
I don't know. Just the the low.
So it's the minimum minus the average, the absolute value of that difference, divided by the standard deviation.
Okay. Yeah.
I would just run the numbers, just put it in, so set it up with calculations correctly, you can adjust things.
Okay. So, questions on that? So then we're comparing these values, this value, to that value. If this value is higher than this value, we have statistical evidence that the data point is an outlier and can be removed. That makes sense. So anytime we do make a comparison or finish a step, we need to write that as a statement. Insert a text box here. Said, when comparing the maximum data point, the GCalc is less than the table 1.43 is less than 1.82. So the data point cannot be too far. And then I'm going to write something similar down here. So every time we run a comparison or do a test, we have to summarize that test in words in the text box. Questions? So let's, for example, everybody okay with where we are now? Any questions? So for example, if we go back here and change this data point to a 1.69 or 12.69, and so that everybody's clear that I changed it, but didn't write that way I remember. Right? If I made a mistake when I transposed or translated, entered, there we go, transcribed this data, that should be at 9. Everything updates, and now you can see that this data point is higher. So now this G value is higher than that. So we have statistical measure or evidence that that is probably an outlier and can be removed. We don't have to remove it. And in fact, if you have 5 data points, I'm not sure you need to remove it, but you can, right? If you decide to remove it, what I would recommend you do, data over, so leave your original data set, copy it over, remove that point, and it will update everything. Right? You had to go back and change your confidence level. You will no longer have to run a new Grubbs test because we only removed 1 point. But I would never remove data from the original. Like the original data that you put in Excel should always stay there just in case you make a mistake. You can go back. A 0. So I'm going to go back to where we were. So if you want to remove a data point, you have to have statistical evidence to do it. And I would also recommend you have something else, right? Like in your observations of that, it just didn't, like the color was different, or something spilled, or your burette was leaking. Don't just rely on, I would recommend not throwing out data just because of the Grubbs test. You can, but I would always recommend that you keep as many data points as possible unless you have multiple evidences that it should be removed. Questions on that?
Some of you had that with your titrations, because you're going to be doing this with all your ocean water data as well. Some of you had that with your titrations, where you're doing a titration and then you're saying like, oh, this doesn't make any sense. Should I just do it again? And you're like, no, because you're statistically going to see if it needs to come out. And if it does, that's where you should have made these additional observations in your notebook to have further justification.
Did everybody hear that out there in virtual land? Nobody's shaking their head. All right. So that's the Grubbs test. The F test is done in a case 2 t-test. So in a Grubbs or F test, we are comparing the precision of 2 data sets to see if they're the same. Since we're doing a case 2 and we're trying to compare those, the way we compare them depends on the precision of those 2 data sets. If the precision is the same, we compare them one way. If it's different, we compare them a different way. And the way we make that determination is with the F test. So I'm going to go over here and do the F test. Right? So like everything else, we're going to have an F calculated and an F table. So when we do the F test, the calculated is the standard deviation of what they're calling 2 squared divided by the standard deviation 1 squared. Right? But the F calculated always has to be a number greater than 1. Right? Which means that the one you put on top needs to be the larger standard deviation. That's on page 69 and 70 is the calculation and then the table. So if we go back here, Which one of these two standard deviations is larger? Barrel 1 or barrel 2?
Barrel 2.
Barrel 2. So we're going to take that one squared divided by that one squared. So the larger one squared divided by the smaller one squared. That's going to be sure. So when we look up the table value, you're going to look at, it's got the table has degrees of freedom for standard deviation 1, degrees of freedom for standard deviation 2, which we will share in a second once Simpson gets on. Oh, there he went. So you can see, you're running the mouse. So standard deviation 1, standard deviation 2. So in this degrees of freedom, so we had for the one we called 1, which was barrel 2, had 4 data points, so standard or degrees of freedom of 3. And for the second one, which was barrel 1, had 6 measurements, so degrees of freedom of 5. So the number we put in is 5.41. Questions on that? The other thing is that I would try to remember whatever you call number 1, you need to call a number all the time. So later when we do the t-test, we will call 1. So barrel 2 is now our first data set. Barrel 1 is our second data set to be consistent. Okay? All right, so we're doing a comparison. We're comparing this to that. The F calc is less than the F table. 2.65 is less than 5.41. So the precision of the two data sets are assumed to be equal. At the 95%. So if you're following along in your book, you will see that there's 2 different t-test equations. One when the f-test says that they're the same, and one when it says they are different. So we're going to perform the case 2 t-test now. So if you are in your book, you can follow along and calculate those equations. Excel, if you've turned on your data analysis package, hopefully I have not.
What are you doing right now?
Turning on my data analysis package. I
Uh,
don't remember how to do it.
I don't know how to do that either.
It's under. Pretty sure it's under preferences. No, properties. Of course, we might have to do this the old-fashioned way. Keep going back in circles now.
Go to tools.
That is. Thank you. So, somewhere or another, if you have a Mac, it's under Tools. If you have a PC, it's someplace else. You need to turn on your Data Analysis Tool Pack.
If I have a PC, but I have absolutely no idea how to do that, what should I do?
You'll have to Google it, and we'll come back to you in a second.
Okay.
What?
I said okay.
So if you go to File, Options, and then there should be an add-ins there.
Where's options?
Since you got it.
Oh, it's in more, I see. Is it in formulas?
So if you go under File and then Options, it'll pull this menu up, go into Add-ins. Okay.
Okay.
You want to manage the Excel add-ins, so you're going to click on Go. Doesn't matter what it says up here. And then you want to make sure that Analysis Tool Pack box is checked, and then click OK.
Okay, thank you.
So again, just to walk PCs through it again, have your file open, go to File, takes you to this screen or some form, go to Options, go to Add-ins, go down here to Go, and then make sure that box is checked, and then click OK.
Now, do you want analysis tool pack
And then under
VBA
Data,
or
you
the
should
normal
see
one?
now Data Analysis. I think that's true of the Macs as well.
There's two options.
Right, did you find it, Elodie?
Yes, there's analysis tool pack or analysis tool pack VBA. Do you just want plain analysis tool pack?
Sorry, we both had you muted. So.
Oh, can you hear me now?
Did not hear a word.
Can you hear me now?
Yes.
Okay, I said mine shows analysis tool pack, and then there's another one that says VBA. Do you just want the plain analysis tool pack?
Yeah, just the plain.
Okay. Thank you.
Yep. Is everybody else good? Okay.
All right. So that's going to allow us to get under Data. This analysis is going to come up here, which is going to allow us Excel to do some shortcut calculations for us. You can still do the long way, entering in the equations into cells like we've done before, but since for time purpose, we're going to show you this. So we're going to do a t-test, and you will see that there are 3 different options for t-tests. This first one, we're not going to ever use. The next 2 depend on the results of our f-test. So when we square the standard deviation, the square of the standard deviation is referred to as the variance. So if we have equal variances, which means the f-test, the f-calc is less than the f-table, which is what we have, we would use this one. If the f-test shows us the other result, where the f-calc is greater than the f-table, those variances are unequal, and we would use this one. So the f-test is done anytime we are trying to do a case 2 t-test and the result of the F-test only tells us stuff about the standard deviations, and then it tells us how to perform the t-test. That makes sense. There's always confusion every year about this. The F-test tells us stuff about the precision or the variances, and the results of that tell us how we do the comparison, the t-test. So we're doing, our F-test said that our variances were equal, so we are going to use this t-test. We're going to click OK. Now this is where I said, we said that barrel 2 was data set 1, right? So when we look for range of variable 1, we are going to select the data for barrel 2. The second one was barrel 1.
Wait, I have a quick question about this.
Yes,
Is it really variable 1 is barrel 2?
that's what we said in the F-test,
Oh, okay.
right? Because we put the standard deviation 1 squared divided by standard deviation 2. We put the larger standard deviation on the top, which was barrel 2. So we called barrel 2 data set 1 in our analysis.
Okay.
Okay. And then I'm going to select an output range, and I'm going to put it right here. Right? There's nothing else there. That's where I want it. It's underneath my label. And I'm going to click OK. And it's going to insert this information. And I say it's going to insert it because if you change any of the data, this is going to stay the same. It just put the data there. It's not linked to anything. So if you change something, you have to rerun this experiment. And because it's in there, just values, I'm going to correct this to what it actually is so that we can keep track. Right? You can see that the mean's the same, the standard variances, the number of observations are the same.
Dr. Budner, I got some kind of error that I've never gotten before on a t-test.
Okay.
It said that my range was not defined or something.
I don't know. We'll have to look at it individually in a minute.
Okay.
Double check the range to make sure you didn't include the average.
Yeah, make sure that when you highlighted the data, you didn't include the average.
Okay.
So it's just this, and then that you didn't include this point here. If you do that, you end up in a giant circle, and Excel gets confused. So now we are going to compare this number so we're going to compare the absolute value of the t-stat to the t-critical. Excel is going to call it t-stat. If I did it individually, I would call this t-calculate. I'm going to and then the two, so we're comparing both sides of the mean. This t-critical, this one here is t. Just for fun. So we can say, since we're looking at the absolute value, right, that's 9.5 compared to 2.3. So again, we made a comparison. We're going to insert a text box. In the case 2 t-test with equal variances. the T calc is greater than T table. 9.57 is greater than 2.30. So the 2 ethanol contents are considered to be statistically different. At the 95%. So, a couple of comments I want to reiterate again. Every time we come to a result, a resolution, we include a text box that summarizes that resolution. Anytime we do a comparison, we should state the comparison in words. T calc is greater than T table, and in numbers. Give the numbers. Because I'm not going to give you any other reason, but that's the way I always see it. Right? And if that's the way I see it in the literature, that's the way I'm going to say you should do it. The last thing that I'm going to ask you to do, well, I don't, we're going to ask you to do, in part because it does it in here, is after you finish a total analysis, so we've done this analysis, you should include another text box and I'm not going to write it. That is the summary of the analysis. And you're essentially going to go through and re-highlight all of the things that we did. Right? We're going to describe each data set again, right? Using the confidence intervals. We're going to talk about the Grubbs test. We don't have to again repeat it, but we found no outliers, so that should be in there. We're going to give the result of the F test, that we saw that these were equally, the variance was equal, and then the result of the comparison. And that is this number 6. So the t-test is here. That's the final analysis that you need to do.
You point out the rest of those boxes too, or like answers to those questions.
Right. So all the text boxes, except for this first one, every one of these, most of these had an individual text box. And this last one sort of summarizes it. And the reason we do that is so that when you go to finish your report or write your report or your discussion, these are instead of having to look at your data again, figure out what the hell you did, excuse my language, right? You can read the text boxes and you can actually, at least to start off with, copy and paste those into your discussion and then do some wordsmithing to make them sound good. Questions, comments, concerns? That was an hour and 5 minutes.
Yes, I have a quick question.
Yes.
So if we only do the F tests for case 2 t-tests,
Correct.
for cases 1 and 3,
No F test
how do we
needed.
know, huh?
How do you, okay, go ahead.
How do we tell whether we should assume unequal or equal variances?
So in a case 3, so in a case 1 and a case 3,
Mm-hmm.
it freaks me out that I can't see myself. Right? In a case 1 and case 3, you are comparing essentially a known value to a confidence interval in case 1. In a case 3, you're looking at the difference between two data points and you're running a simple calculation thereof. So the t-tests are very straightforward, and you don't need to use the data pack. So the only time you use the data pack that we just showed
Oh,
you
okay.
is for a case 2.
Okay.
Page 74 is where all the.
Page 74 is where we start, the book describes the t-test operations.
Perfect.
And there's, yeah, I suggest you read that. There's specific equations to use for case 1 and case 3. Case 3 is more, case 1, you just look at the confidence interval and see if the data point falls in the confidence interval. Case 3 is slightly different, but I suggest you read that.
Sounds good.
Other questions?